the first part, which is on benchmarking and how we value heterogeneous resources. We will have first the two introduction talks. After the first talk by Domenico, if you have really one question related to a clarification to the talk, Domenico will answer it, and we will have one discussion slot after the two talks. So Domenico, if
yes.
you want to start.
Yes, can you hear me? Yes.
Yes, so you have.
And you 15. See my slides.
Yes, yes.
Okay, good. So thank you for this invitation. When we had a discussion with the organizer, we decided to have those two topics, one reported by myself and the other from Marcus, because we considered it important to pass two messages. If the subject of the discussion is how to value heterogeneous resources and then all the implication for that, another aspect is which kind of tools we can use to value them. So this is an area of activity of the HEPIX benchmarking working group, and is the reason why I'm giving this presentation on behalf of that working group. So going to slide 2. So first of all, for who doesn't know the CPU benchmarking working group, this working group was formed in 2007. So at that time, there were only CPUs, and the idea was to define and maintaining a consistent benchmark to describe the requirements of WLCG. The working group then restarted an activity in 2016. And at that point of time, we had at least two subjects to address. One is related to the current benchmark, HEP 6, and what should be the successor of HEP 6. And the other was the evaluation of how to run benchmark on other environments like cloud. So today we are discussing about HPC and new computing architecture. So it's a sort of natural evolution of what in 2007 was considered just the evaluation of the CPUs for the requirements of WLCG. So what I will report here, you will find also in a number of presentation and proceeding of conferences where we are reporting systematically. So I put here two links that you will find in the agenda. So reading a paper probably it's also easier to have a better idea of what we are doing. So how do we use benchmarks in WLCG? Most of you are familiar with that. So we use a benchmark as a currency to evaluate the resources of WLCG, at least in three contexts. One is to procure resources, the other is to pledge resources, and then to account them. So we have several stakeholders that make use of the benchmark scores. So the experiment, the funding agency, the computing side. HEP 6 is familiar to the majority of you, I assume, and most of you are also familiar with those reports in which we report the amount of work done by the WLCG computing resources in terms of HEP 6 days per month. And for who is well aware about the fact that the current course deliver in general 10 HEP 6 per core, so it's easy to do the math to understand how many cores we have in WLCG, more or less. So many of those considerations now have to be moved to something more of CPUs, in particular for all the aspects that have been discussed in the past two days. So is this really a novelty? So to discuss about benchmarks? No, and it's not new the fact that we change benchmarks in our community. So if we consider a sort of a very long time scale of activity in energy physics, we know that in the 80s we had different units to measure performance. There were the CERN unit, the VAX unit, MIPS. Then in the 90s, we decided as a community to move to industrial standards. So we had several spec benchmark and then spec int. And this was the predecessor of HEP 6 that we are currently using. At the same time, the software is changed, also the architecture have changed. So the crucial point and the reason why there is a benchmarking working group that has to follow this is to verify that the benchmark that is used probes the computer resources as the HEP application do. And this is not necessarily trivial. I will try to convince you in a slide, in one of the next slides. So then we need now to include the heterogeneous resources. And we have to do as much as possible this effort of finding a single number that can somehow represent the overall resource. And this is not necessarily trivial. So slide 5, let me try to convince you that there are reasons to look to something else than industrial standards. So first of all, as a working group, we have considered the natural successor of Spec CPU 2006, on which HEP 6 is based. And this is Spec CPU 2017. So we have studied it. It consists of a larger suite with more complex code respect to the 2006 suite. It targets multi-core and multi-threads, but at the end, it has the same application fields as its Spec 2006. And we have verified this using hardware performance counters, studying, for instance, the usage of the front end, the back end, the amount of base speculation, or the effective work, the retiring, what is mentioned by the performance counter as retiring. And there we have found something extremely interesting that is summarized by this dendrogram. The thing interesting is that the similarity between the workloads in Spec CPU 2017 and Spec CPU 2006 are quite high. And the HEP workloads at the same time, they tend to be similar among themselves, and tends to be apart respect to the behavior of those industrial standards. So again, this is probably one of the main motivations to bring us to this consideration. Shall we look elsewhere? And when I say elsewhere, it means indeed, shall we look to our application fields? So shall we look at the HEP workloads? So the idea is that we can move from a context that was effective, worked for more than 10 years, in which we have a benchmark, a Spec 6, but the application field that is separate, to a context in which we have, on the contrary, the HEP workloads from which we get the HEP benchmark. So this will guarantee a high correlation between the throughput of the HEP workloads and the benchmark, and also a similar usage pattern on the CPUs. So when we have proposed this at the beginning, 3-4 years ago, we had clear, reasonable comments about the difficulty on maintaining a benchmark suite, a field-specific benchmark suite. That was also the reason why in 2000 and even earlier we moved to the industrial standards. Because a benchmark has to guarantee reproducibility, robustness, usability on by different users, portability to different platforms, and also be traceable in the way indeed you prepare and maintain the suite. Now, I will try to convince in the next slides that indeed, if this was difficult in the year 2000, today is pretty simple, and is simple thanks to a number of technologies that we are already adopting, and one of them is clearly the container technology. So reason why we have started a work that is extremely advanced, I will say today, that we call HEP Benchmarks. And it consists of three main components, three main concepts. One is the HEP Workloads, the other is the HEP Score, and the other is the HEP Benchmark Suite. For today, I would like that you focus in particular on the HEP Workloads and the HEP Score. The HEP workloads are indeed the workloads of the experiments built in a standalone set of containers. I will detail this in the next slides. So they represent indeed the workload of the experiments. HEP Score is the component that is able to collect the information from different HEP workloads and build a single number, the single number that we need as a benchmark for all the reasons that I have detailed at the beginning of this talk. The HEP Benchmark Suite is a sort of meta orchestrator that we can use to improve the way to run the benchmarks and make more a toolkit and not a procedural approach as that's been up to now. So let me go through those three components. Let's start from HEP Workloads. I already mentioned that the idea is to build standalone containers that encapsulate all and only the dependencies that are needed to run the workloads as benchmark. So this means, and this is pictured in the first cartoon, means that we need an orchestrator that orchestrates the running of the benchmark inside the container. We need to access a reasonable amount of input data. We need to access the software of the experiment from CVMFS. And then we need to produce a set of results typically now is done in JSON format, but it will contain all the information about that allows us to track what was running and then the score. And the score is in event seconds, so our event throughput. This is possible to do that, all that in a single standalone container because there are a number of technologies. One is containers, indeed, and the other is the possibility to snapshot the code in CVM that is currently in CVMFS and build a local copy of what is needed. This gives a big advantage because we don't need to install the full software stack of an experiment to run a benchmark that potentially has to run on a few hundred of events. But we can target only on the software that will be accessed by the application to run that benchmark. So I want to give you immediately the status. So we have a number of workloads from different experiments. We cover generation, simulation, reconstruction. Most of the workloads come from all the experiments. You can see Atlas, CMS, LCB. Indeed, we have also Alice, but we decided not to include as production ready for mainly a reason that is based on the generation simulation is based on Gen3 and has some instability that we have proved. So as soon as we will have the new software from Alice, this will enter again. And you can run those workloads doing Docker run of the image URL in a GitLab registry, and the GitLab registry is linked in that presentation. So how do we build those images? Without going really in detail, but in this cartoon, you can see that essentially starting from an orchestrator code that is on our GitLab repository, and this is the only real information that comes from the experiment, that mainly is 3-4 lines of code that says, for instance, use this script to source in our CVMFS environment, the one of CMS, of Alice, of LCB, and then run accessing those data. So then typically we are able to run. We are able to run in this way in any worker node. So what we do is then to build this pipeline that is able to essentially track what is accessed by CVMFS, and using this technology of CVMFS that is called tracing and exporting, we can export only the software that is needed and encapsulate this in Docker images that are indeed not larger than a few gigabytes. And mainly the size is dominated by the input data when we have to put inside the input data. So we have those Docker images for workloads available, and we are testing there. We are testing extensively, I will say. So for instance, we have tested the reproducibility of the results, the robustness against crashes, the run duration, the spaces that is needed. We continuously run on a number of machines, and those machines you can see here listed. And we have a good feedback that indeed we are able to run a benchmark in a reasonable amount of time. So today, for instance, for this amount of events that you see reported here, we have a very high reproducibility of results with a small spread of less than 1%, and we run in around 3 hours 30. So let me go then to the next component, the HEP Score. How do we want to use the HEP workload? We want to use them, collecting them all together and creating a single value. So this is what the HEP Score does, and it does it in a way that is mainly based on collecting the results, the event throughput of each workload, and then evaluating a geometric average. This concept is generic, so it's applied today to CPUs, can be applied to GPU, or better, to a system CPU plus GPU that runs a workload of experiment. I will come later to that. So this is a quite compact slide that contains a lot of information. Let me just say about that slide that HEP Score is able to give you a number that is comparable in the concept, in the way it runs and gets this number that is done today for HEP 6, because HEP 6 does the same, runs a set of benchmarks and then builds the geometric mean of those benchmarks. And this is the HEP 6 score. We are able today to build in the same way, and we provide in the same way the HEP score using our workloads. In addition, we can create not just a geometric mean, but a weighted geometric mean. This means that we can even weight the different HEP workloads based on the average job mix that is on the grid. Okay, the last component, the HEP Benchmark Suite. This is mainly a toolkit to simplify the way to run the benchmark. So to give it really in a single command line instruction, the ability to run one or more benchmark suite, like HEP Score, the Spec CPU 2017, HEP 6, and collect them all together in a single place. So it's a move from what was done 10 years ago that was mainly a procedural approach. Probably you are familiar with this page of the benchmarking working group, where there is a long, detailed approach to run the suite, to what is now indeed a Docker run of a single image with some configuration parameter. And this will enable also the possibility to run this suite in different data centers and then collect them in a common monitoring environment. Today, we are collecting these, for instance, in the monitoring infrastructure itself. So let me go to the slide 16 and then the heterogeneous resources. So clearly, our idea is that we should be able to move also to evaluate the performance of CPUs plus GPUs. So we should anticipate what will be the need in the coming years. So we started already with the same approach to build the standalone containers for GPUs. So we asked around, and we got in particular from CMS the reconstruction code, the pattern track that we will hear later. And then we got also some additional completely orthogonal software that comes from the synchrotron simulation that is called 6track. Clearly, here we would like to have more application when they are available. What are the challenges that we have seen running and trying already this HEP Benchmark Suite on HPC? So we have seen that we cannot assume many things that are on the contrary assumed when we run on grid sites. So for instance, site admins with root privileges, we can forget. We can forget about using Docker and Docker in Docker that requires privileges. We thought that we could use singularity and singularity and singularity, but we have discovered that not all HPC sites have singularity 353 that enables this possibility to run singularity and singularity. And also they don't have enabled the user namespaces. So that is today a challenge for us that we will try to work around with other approaches. But here would be interesting to understand if the recommendation that were recently circulated to WLCG are valid also for HPC sites or only for the WLCG standard sites. So I'm almost finished. I have just 2 slides. So what is the ongoing work? We are doing validation studies. So we plan to run on many more nodes that the one that I have shown in the previous slides, and on different data centers. So we will report all our findings in one of the upcoming GB meetings. We are planning to consolidate the code base, in particular the one of this method orchestrator that is the HEP Benchmark Suite, to comply with those challenges of the HPC sites of missing singularity and singularity features. And for that, in particular, to focus on HPC, so we have new contributors that can work there. We have some HPC centers that, or people that have access to HPC centers that can give us also their time there to test. our activity. So clearly what we need is important to have workloads, production workloads from the experiment that are able to run on CPUs and GPUs. So those are my conclusions. So I hope that I could pass you the message that from the technical point of view, we are able to build a HEP benchmark for the future. So this will give us the possibility to move out from industrial standards and focus on workloads that are by their nature correlated to the workloads that we run in production. So we will continue to use also HEPSPECO 6 for the time being. This means that we can also make an easy transition and compare the performance with the HEP Score and HEPSPECO 6. For what concern, again, the non-x86 benchmarking, GPUs, FPGA, whatever you would like to benchmark, what is important is to have the workloads from the experiment to do that. Okay, so we really focus on your workloads. And that's all from my side.
Thank you, Domenico. So I don't know, I see one question from Alessandra, so if it is related to clarification.
So for singularities, you can have an earlier version, the one that you say 353 is one of the latest.
Yes, correct. And indeed, starting from Singularity 3, so they restarted to.
Is that these HPC sites have very ancient versions of Singularity, like 2.6, if not earlier.
Yeah. So indeed was one of the members of our working group to provide the latest patches in Singularity 353 because we could not run this Singularity in Singularity with our workloads in version 2, and the version before 353 had also some bugs. So if we have tried this, I would say that it was a byproduct also of our activity to get in 353 these things working. We are trying to see if some of those aspects can work in 2 or backported, but currently, so if there are not security issue with the 353, I would like to ask to the community why there is, what are the reasons not to move to that release in HPC centers.
Sometimes they just need someone arguing the case. Sometimes that's not enough.
Okay, so maybe we move to the next.
Can I still say something?
Yes.
I had my hand.
Yes, excuse me, I missed it.
So it's basically to continue the point that we just discussed, right? So basically the upshot is what an HPC center does is anybody's guess, right? You, Alessandro already said it, you try, let's say, to have some negotiation, right, to make this more usable, but already I would say what a WSG site does is sometimes anybody's guess, right? So there, let's say we have a little bit more control, right? But also there, the landscape is a little bit too, yeah, what's the word? Varied, more varied, let's say, than we would like.
Okay, thank you. Doug, you want also to?
Yeah, the question I had is what HPC centers are you guys reaching out to? Because maybe targeting several big ones across Europe, North America, and Asia might actually help. And by that, I mean establishing contacts with the centers themselves and talking with both the operations staff and the staff who can affect change at these centers.
Yeah, so far
because
we had...
because we're just a small community compared to the scientific communities they have to serve.
Yeah, so currently we have done those at the level of test with the people that were mainly involved in the benchmarking working group. So was done the first attempt in France. because we have a member, an active member from France. And then recently also Tommaso was helping with Cineca just to test it. And there I realized that things like even Git are missing, pip to install something basic are missing, things like that. And then clearly they enabled user namespaces. We would like to access many more. So it's what will somehow happen in the next week and months. If you have some contacts, we would be more than happy to try many more, also to collect different more statistics, let's say, on those issues.